All right. Looks like we're getting a good group of people here today. So welcome and thank you for joining our webinar on the fundamentals of network topology design. We're going to talk about how upfront planning can save you time, money, headaches, and what you need to do. So really quickly, I'm Ben Moore. I'm the VP of Product here at Pika 8. And today we're going to be joined by James Lau, who is the founder and CTO of Pika 8. If you didn't know this already and you aren't familiar with Pika 8, James is kind of one of the godfathers of software-defined networking. And so we're really excited to hear from him today because he's a continual participant in terms of what the world of open networking is doing. In addition, we also have Neil Traber, who is a sales engineer on our team, and he is going to handle questions and answers. He works with customers like Infosys and Verizon to implement these networks in different use cases such as campus, retail, branch, and data center. So speaking of Q&A, we do have the Q&A button at the bottom of the Zoom panel. Please use that to send us questions. We'll take time during the webinar to answer some of them as they relate to specific topologies that James talks through. Otherwise, we'll address the rest of them at the end. So thank you so much for joining. And James, I'll give the floor to you.
Thank you, Ben. Hey, thank you guys for joining the webinar. This is a pleasure. It's really exciting to share with people what we have been seeing in the last 10 years in the networking industry. We started the whole journey with SDN, and when we started the journey, we know that this is going to completely change the world, meaning change how networks work. And we're seeing a lot of changes and a lot of accomplishment already, and there are even more coming in the networking industry. So today in the webinar, we're going to talk about how do you design your enterprise network from access to the data centers. And we're going to also cover when do we consider network virtualization and what kind of things we should consider. Why do we want to do network virtualization? And also we are going to talk about how to build it. And then we're going to show you some of the demo that we are doing already to show you how this whole virtualization virtual network comes together. And then the most interesting thing is that which topology will work the best for virtual networks. All these are interesting topics. And I have to say that when we started the SDN journey, we know virtual network is going to be a huge deal for the networking industry. We just didn't realize this will go so big and so far into every single corner and into enterprise, into telecom, into data centers. So it's a really exciting journey, and we'd love to talk more. Feel free to post your questions in the Q&A or chatting area. Ben will help me to collect the information, and then if we find the right time, we're going to inject the questions into the discussion. And hopefully this is a good discussion for all of us in this 1 hour. So before we get started, we want to talk about what the enterprise network looks like from access all the way to data center. Usually when people talk about enterprise network, they are thinking about on-prem access only, meaning that, hey, I have an office. How do I set up the office network? How do I connect the users into the office? But if you think about what has changed in the last 10 years, office now is not only for people, it's also for a lot of robots as well, or a lot of sensors. So now the enterprise network, the on-prem access network, is not only for people to take a laptop into the office, set up the connection and start working. They also control your TV, your projector, your temperature sensor, your cleaning robot on the ground, or even cameras on the wall, car keys to enter the building. So it's set up for a lot of things. And these things is different from human. Human has an identity, but these things come and go, expand and shrink all the time. So on the on-prem side, we're seeing a lot of challenges in setting up the on-prem access network. Security is the top issue. So for example, if you think about today's enterprise network, if you need to set up a camera, what do? You have to set up a network for the camera. You have to make sure the camera cable go all the way to the right port and connect to the right port, right? A lot of people will say, hey, a lot of cameras are wireless, but if you think about it, the wireless camera is unstable. It can be hacked. Sometimes it's just go offline. And when you set up the system, you always have to have network engineer to set up the connection for the camera. So this is difficult for the facility planner, and it's difficult for the network operator as well. All because of the security, all because of the flexibility. So when we are designing the access network, we have to think about security first, and then how do we scale or make it flexible so that other people can build on top of the network infrastructure without disrupting the traffic of other network users. So that's the on-prem side. Even though a lot of people moving their compute and storage into the public cloud, many enterprises still have to maintain their own private cloud. And for many reasons, for privacy reasons, for compliance reasons, for data sensitivity, in the future for AI, this kind of things will continue to go. So for IT, not only you have to set up an on-prem access network, you also have to plan how do I connect the on-prem network to the private cloud. And then when you are building the private cloud, you of course, the first thing you think about is scalability. How do you scale the data center? And then from there, you have to think about security as well, because you don't want one group of application to pollute the other group of application. So these kind of challenges are the enterprise challenges enterprise is seeing every day. So so this is the overview of the enterprise network. It might be helpful that since we are learning from the leading enterprises, we work with a leading SI company who set up 3 buildings. Each building has 7 floors and hundreds of users and thousands of devices inside the building. They come into the building every day. Since they are SI, their business model is that they have different groups of people working for different clients, and each group of people can only access the project, the related project in the data center. So if you think about that kind of environment, you have one engineer working on, for example, HP project today. Tomorrow, they're gonna this engineer move to Dell project. How do you guarantee that the material or the documents of the HP project are not copied or being transferred to the Dell side, right? So you need to make sure the users, when they log into the system, they can only access certain documents and certain storage. That's the user side. Usually people solve the problem with identity. What about camera? You set up one camera for one building for a group of people. Tomorrow, you need to set up another camera. And these 2 cameras, even though they don't talk to each other, they have to talk to appliance in the data center, both of them. And you want to make sure that the camera cannot access the data of other network or other application, because people can hack the camera and eventually go through the internal link to the other side. So you are now seeing the enterprise challenges that you need to have flexibility and you need to maintain the security. And in the meantime, networking engineer, networking operator is sitting in between. Everybody requires the changes, and everything I change can change the whole network. So being able to separate the physical network from the real workload or workflow is going to be really important. So with that said, when we're designing the network, we have to ask ourselves, what kind of things do I have to consider when I set up the network? So I'm always, when I talk to customers and help them to design the network, the first thing I ask them is that, well, maybe before we start saying that, how do we design the network? Let's think about how do I operate the network first, right? Do I need to be on site most of the time? So we have one customer who has 2,400 stores in the US. Their network engineer, of course, cannot be on the site all the time. So they have to remotely working on the network. Even when they are setting up the new store, they cannot be personally there. So they have to rely on a contractor to set up the network. So that brings up a very interesting problem that the contractor, even though they are network savvy, you give them the design, they go on site one day, connecting all the cables, testing everything is okay. And the other day that when you are testing the network, you before the store starts, you shut down one switch, all the connection go to the other switch, and then you find out one cable is wrong. So what do? You have to start troubleshooting the problem or even asking the contractor to go back to the store to test it. And this is not only in the store, this is happening in the data center as well. So when you are setting up the scalable data centers, some of the data centers are so remote, you cannot be personally remote or on site. So you have to set up things in a way that even if they connect to the wrong cable, you can quickly recover from there. You don't bring down the network. And you have to set up the network in a way that if you make one line of change, the fail zone is only on this subnet. It won't propagate through the whole network and bring down the whole network. So that's the first thing you have to think through, that what kind of things that, how am I going to operate the network? And then from there, you start to think about, how do I secure my access network? Because on the access side, it's not only that you have to protect the access network from the external attack, because today, most of the people, when they think about security, they're thinking, hey, I have the gateway protection over there, so nobody can go from internet to my site. But guess what? Most of the time, the problem is not from outside to inside. It's actually within inside. So we have seen, if you Google the internet, you will find a very interesting case that where in Las Vegas, there is a fish tank with the internet connected sensor to control the fish tank temperature. And then people figure out how to hack the sensor, and then eventually go through the sensor connection to go to the casino's database, and then just basically download the whole database out of the casino. So this is the real case. So security on the access side is not only that you cannot only just plan to protect on the gateway, because inside the campus, everything has to be protected. So zero touch provisioning is going to be really important. Network access control is going to be really important. So, and that's a security. And when you're considering security, you have to think about, hey, how do I minimize the security scope so that when people add or remove the users, they don't have to call network operator and say, can you make this change for me? Or when people create a new organization and move the people around, they don't have to call network engineers and say, can you change this guy's VLAN for me? And when you move the people around, or some people leave the company, you don't have to call network operator and say, can you disable this guy for me? So that requires not only the planning, but also some of the automation as well. And on the data center side, you have to think about scalability, right? How do you make sure the network is still stable with hundreds of switches? Today, most of the people think about, hey, if I have 5 racks, I can easily add the 6, add the 7, and that when you are adding those racks, you have the template that you can do to make sure that it's a minimum disruption to your network. But you have to also think about that, how do you minimize the change scope so that when you are adding new racks, the addition of the new rack pose no threat to the existing infrastructure. So all these things are the design engineer, the network design engineer have to think about before they start the operation. So with that, that leads us to network virtualization. And I assume that many of the audience have already know network virtualization and EVPN, but let me just take 2 minutes to go through network virtualization concept. The concept is very simple. You want to have an underlaid network. It's almost like a bare metal network that every connection is stable. It's very easy to add new switches or new capacity to the network without disrupting anything. So the configuration of the underlay network has to be super simple, easy to add, easy to do cookie cutting addition to the network. And once you have so how do you build that kind of underlay? It has to be secure, it has to be scalable, it has to be stable. So traditional network basically saying that, hey, there is no underlay, there is no overlay. The way we built the network 10 years ago was that we basically say, hey, we have a layer 2 network and we have a layer 3 network to connect the layer 2 together. And in this way, all the people share the same attributes, go into the same layer 2 network. And then they go through layer 3 network to talk to another group of people. And if you replace users with application, it's the same concept. The related group of applications are placed in the same layer 2 network, and they go through layer 3 network to talk to another group of application. And the reason going through the layer 3 network is because layer 3 is much more scalable, and it's much easier to put firewall in between to control the flow of the data. So you cover the security, you cover the scalability. The problem of the traditional design was separating layer 2 from layer 3 is that you now have the concept of localization. You have to put the application in the same place, or you have to put the user in the same place so that they can share the same layer 2 and then connect to other group with the layer 3. That doesn't work in today's virtualization environment, meaning that storage has been distributed and virtualized. Server has been distributed and virtualized. Even for user, they don't come into office to sit at the desk every day anymore. You can literally argue that users are virtualized too. You can work in the office, you can work in your home, you can work on the beach, you can work in a conference room 300 miles away from your office, right? You are moving around. So how do you make sure that when they are connecting to the network, they are not just doing the traditional layer 2, because the traditional layer 2 cannot go across the location like this. So with that, if you separate the network to say, okay, underlay network, we separate underlay from the overlay. The underlay is totally built by layer 3. So you lose all the localization. That means that you reduce the broadcast domain and you reduce the security breach, you reduce the possibility of layer 2 meltdown. But in that case, if you build everything on layer 3, now you have to VPN to everything you are trying to access. That doesn't work either. So if you separate the underlay from the overlay, let's say underlay right now is built with layer 3, everything is connection based. You can use the OSPF or BGP to build out the topology. If you need bandwidth, you can use the ECMP to aggregate the speed and the redundancy to get the redundancy as well. And in this case, you don't need VRRP because no server is going to connect to the underlay network. All of them will connect to the overlay network. And you don't need MLAG because you don't have layer 2 domain. So this kind of layer 3 network is very scalable, but in terms of application environment or user environment, is not very useful because now you have to set up a TCP/IP connection, or you have to use a VPN to access the data you want to. So with that, once you have an underlay network, you start to build overlay network, which is contradictory to our past learning that layer 7-layer network, right? You build layer 1, layer 2, layer 3, and then on top of that, you run layer 4, layer 5, layer 7 on top of that. But now with the overlay and underlay, on the underlay side, you have layer 1, layer 2, layer 3. And then on top of that, on top of layer 3, you start to build layer 2, layer 3, layer 4, and layer 7 on top. So with the virtual layer 2 building on top of the physical layer 3, you now have a virtual network that you can make it work. So how do we do that technologically with the technology? We're going to go over that in a bit. But with this kind of overlay network, you now have a way to virtually pull things together with the layer 2 domain, and all those things used to be localized now can be distributed, but virtually localized. So this is basically done by using VTAP. VTAP is called Virtual Network Terminal Endpoint. It will just build up the endpoint on top of the layer 3 network and then create a layer 2 from on top of that. So that's the concept of the EVPN, and I think it's enough talking. Let's look at the diagram, because I'm an engineer as well. I love diagram. Diagram is much easier to understand. So this is an example of a campus environment. In the campus environment, it's very different from data center environment, where racks by racks of servers that all have dual homing and connect to top of rack switches. In the campus environment, usually people build the rooms or the hubs. Each hub will maintain one floor or multiple hubs in the floor. And in the past, 10 years ago, we were basically using old technology like what is that technology that we used to use to basically just connecting a lot of switches then with the ring topology. But basically today, most of the people started replacing those topology with the spine leaf technology. So let's look at the floor 1 first. If you look at floor 1, this is basically a spine leaf architecture. It's not as visual as the spine leaf from core to the hub. But if you look at floor 1, you basically have two spine switches connecting to a whole bunch of access switches together. Okay, each switch will have 2 connections to the spine switches. So this provide active redundancy. In the past, if you build up this kind of things on floor 1 and make it layer 2, then people will tell you there is a very serious risk that you can melt down the whole floor if there's a layer 2 storm running. But if you are doing layer 3, then there is no storm. But so in this way, you basically build up all the connections, all the black wires or BGP connections that build on layer 3. And then from there, you put VTAP on those access switches like AS4625, or these are edge core switches. Edge core has the extensive line of gigabit Ethernet switches with PoE or without PoE, right? So this allows you to build the virtualization VTAP on top of those access switch. So then you have your server, laptop, IoT devices connecting to the access switches. And then across the network, you then dynamically connect, associate 2 devices or more devices into a layer 2 across the layer 3 functions. And then from there, once you build up the campus environment, when you are designing the network, you also have to think about how these overlay network is going to go through the WAN network to the internet. So you need to have a WAN device connect to overlay routers, and these routers terminate the VTAP so that the VTAP traffic will come out of the overlay routers and go to the external network, just like the typical traffic. So far, so good. Any question?
James, I think there was one question, and there was also a comment. So first, the comment, I think the technology that you're trying to remember was token ring. This is from the audience. I don't know if that.
Yeah, token ring is a pretty old technology. There's a way that you can have A switches and connecting with proprietary cables together, and then it just escaped from me that I just don't remember the term, but this is the term that a lot of people, even today, a lot of people are still using it. It's an Ethernet technology, but it just doesn't come to me.
Okay, well, it happens. No worries. Even to the best of us. So, so question for you on this particular topology, which is, what can't I do with my current network that investing in a move to a new fabric will do for the organization and ultimately the operator, right?
Yeah. Oh, that's a great question. So a lot of people have already built a layer 2, layer 3 network in the way that layer 2 is on the edge and layer 3 is basically aggregated switch. And so the great thing about virtual network is that virtual network is not only exclusive to VTAP. VTAP is actually a bridge between the local access network and the virtual network. Meaning that if you have a local network running layer 2, VLAN 200, for example, you already have a local network running VLAN 200. You can easily create a VTAP next to it, and then connect all the VLAN 200 traffic to a VTAP running, for example, a different VNI. VNI means the virtual network ID. So basically just say you have VLAN 200, all the VLAN 200 will join VNI 10200, right? So in this way, the VLAN 200, local VLAN 200 can start to connect through 10200 to the remote VNI connections to another VLAN, right? That VLAN could be 200, could be 300, could be anything. So this provides a way that you can migrate from the traditional network to the new virtual network. You don't have to completely tear down the network and then start building a greenfield build out from there. You can start migrating your network one by one to the new network architecture. Great question. So with that, we're gonna talk about the data center side. I think campus side is exciting, and data center side is even more exciting because on the data center side, excuse me, on the data center side, the problem is actually even simpler. Most of the time, data center is homogeneous, meaning that you have a lot of racks and racks of servers. Even though it looks like on the scalability side, it's really daunting to think about how do I build 2,000 racks of networking together. But if you look at the way they operate, each one of them have very, very similar configuration, right? So first thing to think about is that how do you plan on the top of rack switches so that when you replicate the racks, you actually can just use a template to generate the configuration or minimize the configuration so that when you are creating the new racks, you don't even need to customize it for it. So there are basically two ways of building the three ways of building the top of rack technology. The first one is that using MLAG on top of rack. And this is a traditional way that we are all familiar with, that in the data center, before network virtualization, we basically set up the VLAN on top of rack, and then from top of rack we connect to the aggregation through layer 3 and start using aggregation switch to exchange the layer 3 routes to connect the layer 3 routes together. So MLAG is definitely one possibility to build out, and we're going to show you how that works. A new technology that we are seeing is that by replacing, because MLAG is kind of proprietary technology. If you use PKI MLAG, is a little bit different from the Cisco MLAG. Cisco MLAG is a little bit different from Arista's MLAG, right, or MCLAG. So that's why some of the people say, hey, I'd rather have a standard technology to work on the multi-link technology. So with that, EVPN actually created a standard called multi-homing, and this is gaining momentum. A lot of people find it very, very useful. It's a standard based, and it can scale even better than the MLAG, and we're going to show you how this works. And of course, you still have the traditional VXLAN that you can use to build your network. VXLAN, there are pros and cons of each approach, and we're going to go through that in a bit. So if we go to the virtualization, let's start with the most basic configuration. Basic, it doesn't mean that it's bad. It just means that this is the way we have been using, and we can add virtual network on top of that. So in the traditional way that when we add a server to a rack, we have a choice that we can just set the rack into the same layer 2 domain, or separate layer 2 domain, but basically it's a layer 2 switching domain. So you set up 2 top of racks. So let's use the box over here to show you. You set up 2 top of racks, they form a VLAN, MLAG together, and they share the same VLAN partition on the ports. Each server is connecting to one port on each top of rack. And these top of rack ports are basically predefined, port 1 associated to port 1, of another top of rack. Port 2 of this top of rack associated to port 2 of another top of rack. And in this way, when people set up the rack together, they can just connect the cables in pairs, and then you got the active bandwidth out of this one. Layer 2 domain is pretty easy concept that people feel comfortable of programming. And then from there, you start to build the VTAP for underlay network. So the underlay network can be run with the BGP unnumbered. The good thing about BGP unnumbered is that it's a minimum configuration that you have to set. You don't have to assign the IP address. You don't have to do all those tedious change every time when you add a new rack. By using BGP unnumbered, it will automatically assign the IP addresses for you. So in this way, when you roll in the new rack, you can just connect the cable up, and it will start propagating the BGP information for you. So basically, the dividing line of layer 2 and layer 3 is on top of the rack. So in this way, you got active redundancy, and then it's easy to run the layer 2 network out of this one. And you still get the network virtualization. So what is the problem of this? The only problem is that it's a proprietary technology, meaning MLAG is a proprietary technology. So every configuration is a little bit different. If you have Cisco, Arista, PK8 at the same time, their configurations are all a little bit different. So that's the MLAG system. And then we're going to talk about a little bit multi-homing. This is a new concept inside the EVPN concept, that you can see that on the top of rack, now we don't have the MLAG connections anymore. So we only put VTAP on top of the top of rack switches. The layer 2, layer 3 dividing line is still on the top of rack. So the blue box, just like the previous slide, the blue box is the underlay network with the IP layer 3 network. The dividing line of layer 2, layer 3 is on top of rack, so that servers still maintain active redundancy to the network. Okay, so what is the difference? The difference is that now it's using EVPN technology to propagate the pairing information between the two top of racks, instead of using proprietary MLAG technology to propagate the lag information. So that's the huge difference. And with this, you got standard-based multi-link technology to go through the top of rack to build the virtual network. You still get the active redundancy, and it's a standard-based. And not only that, there are two more benefits that people don't, it's not so obvious. The first one is that most of the MLAG technology are only limited to 2 switches. The EVPN multi-homing technology actually allow you to use more than two switches or 2 VTAPs to form multi-links. So this gives you the possibility that if you have a server who has 4 NICs, now you can actually distribute through 4 top of racks instead of 2 top of racks. Some people might want to have that option, that if you're running, for example, AI traffic, or you are running different type of traffic, so you actually want a different setting on the traffic type on the server side. So in this way, it allows you to use different NICs to send different traffic. So that's one not so obvious benefit. So that's one. When you have when you use multi-homing, you actually can scale more than 2. You can actually use 4 or even more for the interconnection to aggregate things together. And it's a standard based. It's basically still allow you to do active redundancy. So what is the disadvantage of using multi-homing? The one slight disadvantage is that everything has to be well planned, meaning that the ports have to be coordinated together, so that when you have a port, so for example, my server A, if I have a NIC 1 connecting to top of rack 1 with port 1, the other port better be identified as, for example, 1, right? So it's basically port 1 on this side, port 1 on this side, and you have to pre-program that in your VTAP. Otherwise, if you plug it into the wrong port, VTAP will be completely confused because they don't know which port is connecting to what. So these have to be carefully planned and then carefully executed. This comes back to our previous comments that, hey, if I want to use the virtual network in my data center, but I'm not the one building the network, I actually have a contractor to come in to build up all the cables. How do I ensure the cables are correct? So I have to do a whole bunch of things to make sure it's correct. Because if they connect to the wrong port, not only it's going to cost me another trip to correct the cables, I'm going to have a disaster before I realize it. So that's the slight disadvantage you have. Oh, I forgot to mention one thing about the benefit. Besides that you can scale from 2 to 4 on the multi-homing. Multi-homing also allow you to choose whether you want to use the what is that protocol? The lag protocol, LACP, or not LACP, to build up the connections. most of the MLAG will require you to use LACP, and some of the servers do not support LACP, so that becomes a problem. But with the EVPN, it's a standard-based. It actually specifies that you can support LACP or you don't have to support LACP. So that's another flexibility people have.
Hey, James.
Yeah.
This is really interesting. Couple of questions. One that came in is on this particular diagram, are the top of rack shown in this multi-homing example? Are they traditional top of rack, or are they enhanced top of rack with hardware VTEP that is built in?
Oh, great question. These are usually the next generation, new generation of switches that with the ASIC capability to handle the VTEP. And that's actually a very good point, that if you have top of rack that's already running layer 2, and they don't have VXLAN or VTAP capability, using MLAG might be better solution than using this type of switches. Because
so maybe I can ask a question based on that
mm-hmm.
too, James, and for some of my own education as well, because we see a lot of at least in enterprise engagements, the DevOps teams are constantly pushing to virtualize everything, right?
Mm-hmm.
Want to move towards bare metal, Kubernetes versus traditional hypervisor stuff. We're talking about MLAG and multi-homing.
Mm-hmm.
Which is better? What do you see more customers moving to? And then I would say the second part to the question is, are there use cases where folks on the call might want to still look at MLAG versus EVPN multi-homing?
Yeah. So, that's such a great question. So, in the data center, from what we're seeing in the field right now, majority of the enterprises, when they migrate to network virtualization, they are considering multi-homing. Not that they don't like MLAG, it's just because multi-homing go very well with the whole concept that fabric all the way to the host, right? Because some of the people might want to have EVPN or BGP go all the way to Kubernetes server, even though it's a kind of high risk. So when you are planning on that, be careful with what you are wishing for, because that usually means that the server now has a BGP capability. So it might create some of the routes that you don't want to see, or if the server is hacked, then posting certain BGP route to the network, you got the disaster on your underlay network. But with that said, majority of our customers are thinking about using multi-homing because it's an open standard. It's not proprietary solution. If it's open standard today, you are using PKI with the open network. Tomorrow you say, hey, I have some of the traditional racks, but those are running Cisco, Juniper already with the multi-homing. You can guarantee that the old racks and the new PKI rack can work together without any problem. Not that the MLAG is going to pose any problem. It's just that for MLAG, you have to do a lot more tests to ensure they are compatible. So in terms of customer traction, I think I can safely say about at least 70% of the customers we are working with, they all use the multi-homing as the topology. Do people still want to consider MLAG type of a consideration topology? Yes, there are many people who have built the racks with special application consideration, QoS, for example, access control, for example, even latency is really critical. If you build everything on top of rack with the multi-homing, then latency will be impacted because you have to go through the translation of layer 2 to layer 3 and eventually back to layer 2. But if you have those applications in the same rack sharing the same layer 2, they basically can go through the fabric to find each other without going through multiple hops. So that's one possibility. So if you have a rack that's with server that's already optimized for local compute and local clustering, you don't necessarily want to use multi-homing. You can stay with the MLAG And then only when you need to get to the remote resource, you can go through VTAP to the other side. That's a great question.
That's great. Thanks, James, for answering that.
Yeah.
You know, pleasure of being moderator and sort of master of ceremonies. I get to make sure that we're moving along timely. So we've only got about 14 minutes left today. I do want to remind everyone that we will share the recording and the slides, but let's move on to the next part of the presentation, James.
Great. So with the limited time, I think I want to quickly mention this one because not a lot of people think about this this way. Most of the people want to optimize the whole infrastructure for active operation, but there's still a room for people to use generic VXLAN, meaning that you don't form the pair of top of racks into active connections. Each top of rack is still run as an independent VTAP. So how does that work? If I have a server, I have 2 links to the top of rack. Does that mean that I have to set up a separate network to the top of rack? Yes, you do. So in this way, only one of them will be active because the other one cannot send the traffic. Yes, that's the case. So you end up with an active standby connection on the server side. But the beauty of that is that the ports are now independent. So if you have a contractor to come in to connect the cables for you, then if he connect randomly to different ports, or he mistakenly connect to wrong ports, because the 2 VTAPs are running in parallel or independently, the network will continue to work. So when you switch over to the other side, we have technology. So this is something that we validated with one of our key customers, that when you migrate from one link to the other, all the MACs will automatically forward to the other side. We solved the MAC of mobility problem, and then all the traffic will resume on the standby traffic. So this is not a very fancy design, but it solves very, very fundamental problem that if you have to be remote and the operation team is independent from the design team, you want to make sure that when they are setting up the topology, if they connect to the wrong cable, even if you check everything, when failover happens, everything will continue to work. So this is one of the benefit of VXLAN. So disadvantage, of course, is that you only get half of the bandwidth on the server side. But for a lot of application on the server side, you only need 1 NIC because each NIC is 100 gig, right? But I want to clarify one thing. It's not that one top of rack is in standby mode. It's actually the server has 2 links, one in active, the other one in passive. But by distributing the application, the server's traffic on 2 top of rack, you still have full capacity on each top of rack. Okay, so this is just a quick summary before we get into a demo that to design the modern network, really you want to separate the underlay and overlay because on the underlay side, you can use a spine leaf layer 3 architecture so that it's easy to replicate and easy to scale. On the overlay side, by layering layer 2 on top of layer 3, you now have a flexibility. And the beauty of that is that if you are working on one VLAN on the layer 2 side, you can make sure that it doesn't impact your underlay network. It doesn't impact other layer 2 network as well. And most importantly, you want to build it with the open network, because if you lock into proprietary solution, all the new technology that people are inventing, you basically are locked out of that. With the automation, with the virtualization, all these things that you want to make sure that you go with the open network so you can continue to evolve, continue to replace the hardware when the new functions is available. So methodology, this is very quick that we want to get to the key point side. In the past, when we designed the network, all the network operator or network expert like you will do the planning and design. And then we start to say, okay, let me go over the design, make sure everything is correct. We even set up a small lab and do the testing make sure the configuration is right, and then we cross the fingers, throw them into the network, and hopefully we don't screw up the whole network, right? So with that, I think now we have tools that we can do the verification without running that much risk. And Neil is the expert of this one. Let me hand over the microphone to Neil so that Neil can help us to do a quick look of the how do we validate the design. Neil?
Great. Does everyone see my screen? Can everybody hear me? Okay.
Yes.
Fantastic. Thank you, James. So what James is alluding to, that we are launching what we call our PK8 VLab, our cloud VLab. It stands for virtual lab, where we're going to be able to validate our customers' architectures so we all know before we go. That said, now that you are, that said, what you are seeing here is one of the many labs that we have within our VLab, prefabricated. Yes, you'll be able to edit these. You'll be able to add any and a kind of third-party vendor appliance application that you want to test within this framework. And for those of you who aren't familiar, this is being powered by GNS3. GNS3 is an open source layer 2, layer 3 testing environment. For those of you who aren't aware, it's freely downloadable. You can find it. It's called GNS3. And it allows you to run both layer 2 and layer 3 full routing and switching within this virtual environment. And so what we have here is an EVPN mesh. What you are seeing here is one of our beginner labs. It also is being managed by Amcon, which of course is our automation and management platform for those of you that aren't aware. And what you see here is we have our underlay and overlay separated. The underlay network, of course, and in this example is pure BGP, iBGP, and eBGP. The eBGP, of course, being run across the underlay, also allowing us to better troubleshoot, but also take advantage of things like BGP unnumbered, so that it becomes very easy to template and automate and create our EVPN VXLAN mesh.
Hey, Neil, real quick question coming in hot. Does this support EVE-NG?
Yes, we do support EVE-NG as well. What you are seeing us use is our Picos V, which is also freely downloadable, and you can come register at our website and download it. And as a part of this webinar, we will reach out to you and help you get set up with it and within our VLab. So yes, Picos V actually is fully available to run in all of the major hypervisors: QEMU, VirtualBox, Hyper-V, VMware, GNS3. So yes, you can pick what and how you want to use in a testing environment. And so just in the interest of time here and moving along with our demo, we have two kind of separate pieces in this mesh. We have a traditional EVPN VXLAN network here being routed, as well as an EVPN multi-homing set instances as well. So you've kind of got a full EVPN mesh, and you see distributed gateways. So something that James was alluding to before was the fact that more and more people, yes, the old company standard has been VRRP for almost 2, if not 3 decades at this point. A little long in the tooth, it's still getting extensions, but the newer kid on the block is Anycast. And we fully support Anycast for being, depending upon where and how you want to use, whether it's part of the overlay for your VLANs or in the underlay, but it allows you to have a fully distributed gateway across your entire mesh. So that same 192.168.10.1, that same core router is distributed across the entire infrastructure. So you've got the same VLAN, same gateway, right? And also not being limited by VRRP's simple 2 master slave. You now get much more enhanced and scalable redundancy, failover, and routing. So as a part of that, you can see I've got several hosts set up. 2 bare metal Ubuntu servers, 2 bare metal Debian, of course, as James also mentioned, Whereas there be dragons when it comes to routing to the host, because yes, we're introducing new BGP routers to the network. So you will want to work closely between NetOps and DevOps to make sure that all of those routes and those things doing routing, especially down to your new virtualized hosts running Kubernetes and Docker or VMware, to make sure that those things that are allowed to advertise routes are allowed to advertise routes, and those that are not using route maps and ACLs, so that yes, you keep your network protected while doing so. Now, that said, we're going to very quickly here. GNS3 allows you to open up some, we call these web console tabs. If you're using GNS3 in your own environment, you can actually open these terminals in your local terminal of choice, secure CRT, whatever you use on your desktop. I'm doing this all web through the browser. So I'm going to ping across my EVPN fabric, and I'll show you the fabric as well, from this Debian host here who is tagged, housing multiple IPs. It's actually multi-IP homed across multiple VLANs. You can see VLAN 10, VLAN 20, VLAN 30, VLAN 40, respectively, each with their own separate subnet. And it's going to ping across all the way to this Debian host here, which is via 192.168.10.103, running on a multi-homed, yes, interface, but as multi-home to both leaf 3 and leaf 4. So we're going to log into our Debian host 1 here that you'll see over here, host 1. So, oops, I closed it. That's okay. We're going to reopen it. Oh, that's leaf 1 again. Sorry, we'll do host 1 would be nice. There we go. I'm going to log into it. Give it a moment. Let me raise this up so we can all see what I'm doing. And I'm going to show you the IP addresses here. No smoke, no mirrors. And so you'll notice there's my 192.168.10.100, .20.100, .30.40, respectively. I'm going to ping 192.168.10.103. And now you'll see I'm going all the way across. Now, we want to see what the magic is, and we want to know there really is no smoke, no mirrors here. So we're going to now actually go to our, yes, we're going to go to our other host. We're going to go to leaf 1. And this is leaf 1. And I'm going to log into it. This is Picos V, by the way. I'm logging into it, by the way, whether it's virtual Picos or physical Picos, it's all Picos to us, and AMCON recognizes it the same way as far as management goes. And so all of our commands, our command line, it's all the same across the board. I'm going to say show VLANs, just so you can see my VLANs. I'm going to have to give it a minute. And now you can see who I have tagged and untagged in my VLANs, and 10, 20, 30, 40 all have TE113 and 114 respectively. And now I'm going to say show BGP EVPN. By the way, you also fully support tab completion, EVPN route. You're going to see lots of really cool routes come through, especially type 2 and type 4, because you'll notice how and which and what interfaces these IPs are connected to and how we're learning the routes for those hosts. And you'll notice my route distinguishers, my type 2 and type 4 routes as we go, also recognizing across the board, across different servers. Here's 40.101. You can see how my fabric is fully integrated and fully mesh tied. And
hey, Neil, we got to wrap up here. We're at the top of the hour. We can't keep people beyond. So I want to say thank you for showing what we use internally to help folks design and test their network topologies. So thank you for that. Everyone, thank you so much for attending and your time. I really appreciate it. I know James and Neil do too. I'll speak for them for a second. Really quickly, we talked about what the enterprise network was today. We talked about key things to consider, really security being number one, but also flexibility in terms of users and ability to scale the applications and devices. We did go through a number of network topologies, whether it was campus or data center options, MLAG, multi-homing, the VXLAN example that James gave. They were all really great. I hope they were all really useful to all of you. We will send out the deck as well as the video after this. If we didn't get to your question, please email us at info@pika8.com. We will be happy to answer your questions one-to-one. And again, thank you so much. Thank you, Neil. Thank you, James. And we'll call it there. Talk to you next time.